A copper wire length 2.2 meter. This wire, this one, is of copper. Steel wire length 1.6 meter. Both diameter 3 mm, connected end to end. This is copper, this is steel, they are connected end to end. When stressed by load, this is the load. When stressed by load, the net and elongation found this, determine load applied. Given Young's modulus, copper this, steel this. Say Y1 1.1 11 Newton per meter square. L1 2.2 meter. R1 1.5 mm. 1.5 minus 3 meter radius. Delta L1 not given. Y2 says steel 10 k 11 Newton per meter square. L2 it is 1.6 meter. R2 same as R1, it is 1.5 10 k minus 3. Delta L2 not given, and delta L1 plus delta L2 is 7 what? Millimeter. Net and elongation found this. Determine load applied. We have to find this. This is the question. Y1 F by A stress number 1. Y2 F by A same load, same area. Dividing first by second. Y1 by Y2. F by A cancelled in both cases. It is L1, delta L1, L2, delta L2, delta L1, delta L1, delta L2. Take this to this side. This by this, so it will be delta L2 by L2. Take this, these things to this side. L1 L2, Y2 by Y1, L1 it is 2.2, L2 it is 1.6, y2 for this 2, 11, it is 1.1, 11, delta L1, delta L2, it is 4, 6, or delta L1, 2.5, delta L2. Why we have divided this? Anyhow, I want to find this delta L1 and delta L2. This is given. So we can easily find now delta L1 and delta L2. You say this is equation first. Putting in first delta L1, delta L2, delta L1, this is the value of delta L1 plus delta L2 is this. So 3.5 delta L2 is 7, or delta L2 2 millimeter. Therefore, now this is 7 mm. So delta L1 comes out to be 5 millimeter. We have to find load. Either use this equation or use this equation, you will find load from first. Either use first or second. F. It is Y1, it is A. It is delta L1. F. Take this to this side, this to this side by L1. Y1 1.1 10 की 11. Area pi R square 5 1.5 10 की minus 3 square 10 की minus 6 delta L1 is 5 milli. Ten की minus 6 5 milli minus 3 by L1. L1 is 2.2. Solve it. It is 1.8 Newton. two wires diameter 25 centimeter, one made of steel, other of brass, are loaded as shown. The unloaded length of steel wire is 1.5 meter and of brass wire it is 1.0 meter. Compute and elongations. This is steel. They are loaded as shown. This is brass. It is 4 kg. It is 6 kg. It is 1.5 meter. It is 1 meter. Given Y1 steel, 210 की 11 Newton per meter square, Y2 brass, 0.91 10 raised to power 11 Newton meter square. Two wires diameter this. So R1 125 centimeter meter, L1 1.5 meter, Y1 210 की 11 Newton meter square. The force applied here (40 Newton). G also given. Load, it is force. R2 same as R1. meter, L2 1 meter, Y2 9 1 11 meter square, F2 it is 4 plus 6 Y. Now look, on steel the load is this one as well this one. G say not given. Newton. Here only on this wire only this mass is suspended. This mass means 6 kg. What we have to calculate elongations. This is the question. Look here, on this wire, this mass is there, this mass is there. So it is 10. On this wire, only this mass is suspended, only this. So F2 is this. Now Y1 F1 by A delta L1 by L1 or delta L1 F1 by A L1 by Y1 delta L1 F1 10 9.8 by A pi R square L1 5 Y1 solve it. It will be 1.44 10 की minus 4 meter. Similarly, delta L2 it is F2 by A, L2 by Y2. F2 it is 6 9.8 area minus 2 square into 10 की 11 L2 it is 1. Again solve it. 3 minus 4 meter. So these are elongations. If total elongation is asked, then total an elongation delta L, it will be delta L1, delta L2, 1.44, 1.30. This is common. It is 2.74 minus 4 meter. Average depth of Indian Ocean meter. Calculate fraction compression given bulk modulus 2.2, 11 Newton per meter square, and Z 10 meter per second square. Average depth 300 meter. Density of sea water kilogram per meter cube, we know, or it is given. If we don't know, then it will be given. G 10 meter per second square. Calculate compression, fraction of compression, given that B 2.2, 10 raised to power 11 Newton per meter square. Rough work. We know B stress by strain. Stress, pressure, force upon area by strain. So first find pressure. Rho GH, rho G H. It is 3, 1, 2, 3, 4, 7 Newton per meter square or Pascal, anything. Now B, stress by strain, or F by A by strain, or it is pressure delta B by V. We have to find this. Take this to this side. So it is P by B. P. Seven by B. 11. -4. B was this. B. Not 11, B was given 9. So it is -2, no units. Square lead slab. This is a lead slab. It is square, 50 into 50. Thickness 10 centimeter. This is thickness of that slab. Subjected to shear force, narrow surface. This is narrow surface, this one. Shear, tangent direction में, tangent. This is shear force of magnitude this. Lower end riveted to floor. ये floor है, ये fix कर रखा है lower end. How much upper edge is displaced? So how much? Let this edge displace it from E to E dash, G to G dash, F to F dash. ये upper. How this is displaced given shear modulus this. So here F is 9 10 की 4. This is the force. E dash. How much displaced we have to find? EA. It is 50 centimeter meter. Shear strain, change in configuration, EA. Out of E dash we have to find area on which this force is acting. It is 10. This into this. Narrow end 50, 10 की -4. It is 0, 0. This 0 cancels with this 0. It is 5, 10 की -4 meter square. B is given. Sorry, eta shear 5.6 10 raised to power Newton Pascal. Shear stress, shear strain, It is F by A. Shear strain E dash by EA. EA. I have to find EE dash. It is F by A. Take this to this side. EA by eta. F. Nine 10 की 4 A. 5 10 की -4 EA. EA 50 10 की -2 eta 5.6 10 की 9 4 8 10 goes with this, so it is 5 10 की -2 or it is 50 10 की -3 1.6. Here it will be 4. It is 3. Meter. Edge of aluminium cube. Ten centimeter long. One face is fixed against vertical wall. A mass 100 kg is attached to opposite face what is vertical deflection of face shear modulus (25 gigapascal). G 10 meter per second square. This is aluminium cube, 2 dimensions. This is wall, this is fixed. A force, opposite phase, this end is fixed. So this will be deflection. So we have to find this D dash. What is vertical deflection? Length 10 centimeter. Area on which force is acting. Meter square. Mass 100 kg. So force mg. (1000 Newton). Shear modulus gigapascal. Gigapascal. CD 10 centimeter. We have to find DD dash. This is the question. We know eta stress, shear stress, shear strain, shear stress by a shear strain, change in length, change in shape by original shape. It is CD. Eta of A CD by DD dash. I have to find DD dash. It is F by A into CD by eta. F. 3A. Area CD eta. Six, 3, 6, 4, minus 5 by 5 minus 6 by 5 minus 6 meter. Eta was 25. It was 25. It was 25. Say 100 now. And 7. It is 4 minus 7 meter.